here.
Great. 大家好。我的中文不好. So my Chinese is very bad, so I will not inflict that on everyone here. For those of you who don't know, my name is Stephen Fluin, and I lead developer relations on the Angular team. What that means is that my job has two parts. First, my job is to help developers and businesses be successful with Angular. And second, it's to understand what it's like to be a developer who's building applications every day, trying to build and run businesses, and really reflecting those needs onto the team to make sure that we're evolving Angular in the right way, in a way that's going to support everyone. I am a big fan of China. In the past couple of years, I've been able to go to Beijing and Shanghai. I was not able yet to visit Hangzhou, but it is definitely in my plans. I would love to be there. I found everything from the architecture and the buildings and the people to be amazing, as well as the culture, just all of the little places that you can visit. I've always been very impressed by China. Whenever we give a presentation about Angular, we think it's very important to tell everyone how we see the world and think about the things that we value as a team that's building tooling for everyone. And so we always talk about apps that users love to use, because user experience at the end of the day is what ends up making us successful. If we are not making our users successful, then we as developers can't be successful. Angular also cares about apps that developers love to build. We really enjoy whenever we can create moments of success for developers. And last, a community where everyone feels welcome, because we have only been successful in the past because we have so many people that are building Angular applications, that are sharing their knowledge and passion with the world, because we have consultants and trainers and people that are writing blog posts. We have this really rich community, and this is a big part of why we've been successful so far. So today we're here to talk about lazy loading. So I'm going to go through this in three parts. First, I want to talk a little bit about the principle of lazy loading. Then I want to talk about what you can do today in the present. And then I want to end by giving a demo of some of the things that are coming in the future. So let's start off talking about the principle. I talked about this idea that user experience matters and that we are trying to make it really easy to build great user experiences within Angular. And this is actually a really big deal, because when you build Angular applications, you want the applications to be targeting your developers in a way that meets their needs. And so there's this great phrase that the Chrome team uses called perf matters, where oftentimes as developers, we end up getting so caught up into the idea of what feature do I need to build next? What are the bugs that I need to fix? And we forget a little bit about the performance of our applications. But we've seen many times that the performance of our applications directly affects the success of our users, where if you have a slow site, you will lose people, you will not sell as much, your users will not be as successful as if you had a fast site. And so trying to think through this is critical. When it comes to shipping performant Angular applications, bundle size is the number one factor in performance that we tend to care about, because it directly affects the startup time of your application. A lot of people think this is just network, meaning that if I have a slow network, that means that a large bundle is bad, but it's even worse than that. It's both network as well as parse time, because the more JavaScript you write, the more that your browser, whether that's on your phone or your laptop, has to parse. And so there's a CPU involvement that can block the page from being interactive and usable by your users. And one of the most insidious problems that we have in our industry is that oftentimes we don't notice performance problems when developing. We have the application running on our local machine. Developers tend to have very powerful computers. And so we oftentimes don't experience the same thing that our users experience, which can lead us into making bad choices. So one of the things that I want to share, I want to do a little demo. This is my son, Daniel. He loves to do live demos with me. I did not invite him today, though. So what I want to do is I want to look at a very simple Angular application using the Chrome Dev Tools. So if we open the Chrome Dev Tools, there is a feature that not a lot of people know about or use. And this is called the coverage report. So I can zoom in here to make sure everyone can see. In the coverage report, what will happen is Chrome will automatically instrument everything that happens in the browser, all of the scripts and CSS that are loaded. in a way that you can actually measure how your JavaScript is being used. So we've just loaded this Angular application, and we can see that this is in serve mode, so it's serving a whole lot of JavaScript. But one of the interesting things here is that only half of the JavaScript that's been served so far is actually in use. And when we think about performant applications, in an idealized world, every user should be seeing 100% of their application code being run. This would be the world where you aren't shipping unnecessary bytes down to the user. Now, you'll never actually get to 100. That would be crazy, because you need things like error handling and double checks, and not every user is going to use every feature of your application. But lazy loading is a tool that allows us to do much better at this, where by thinking about the construction of our application, we can choose to load only the things the user needs when they need them. And that's really our guiding heuristic as we build Angular applications with lazy loading. Lazy loading allows you to load the right features at the right time. We all build applications with many, many, many features, and we often find that our users only use a small subset of those features. But by lazy loading, we can make sure that we get the benefit at the same time as we're paying the cost. One of the really important things to acknowledge is that in the US, about 70% of web traffic is coming from mobile devices. And the number I've heard in China is that the number is over 90%. With numbers as high as 70 or 90%, if we are not considering the performance of our user experiences, we are not going to be successful. All right, so let's talk about the technologies and the techniques that we use today to build lazy loaded experiences. Lazy loading in Angular is a best practice, meaning that we recommend it for everyone. And the nice thing is that lazy loading is actually built into Angular. We have a lot of tools within Angular, including our build system, that understand this as a first order concept to make it easy for people to take advantage of. Being that it's so easy and that it's a best practice, every application should lazy load. So my hope is by the end of this talk, everyone feels comfortable doing this, and not just in the simplest ways, but also taking advantage of a little bit more advanced techniques that I'm going to talk about. When you lazy load in Angular today, your module layout is what determines your lazy chunks. So today, Angular supports lazy loading at the module level, and we use our router to accomplish this. So if you wanted to see what this looks like, you could start a new application. You could run ng new my app and use the -- routing flag. And then one of the things you can do is whenever you create a new module in your application, you can automatically register it as a lazy loaded module. To do this, you specify that the route that it needs to be configured with, and then you need to specify the module that you want to lazy load it from. And what this will do is when you generate that new admin module, it will go ahead and register that module into the app module, into its routing config that it can find. So if you take a look at the route config that that command would have created, it would have looked something like this. One of the big things that we did in version 8 is that we changed how we lazy load modules. Historically, we would use a string syntax where you would say, here's the string path of my module, and then you'd use a $, and then you'd name the symbol within that file. So $admin module. What we did in version 8 is we actually got rid of that one, or we deprecated that one in order to adopt this new syntax where you have an import and then you have a then. So we're still using the same load children method or property on the route from the router, but now we're using industry standard dynamic import syntax. The nice thing is that by doing this, we now get to take advantage of the native capabilities of editors. Previously with the custom syntax and the custom build system, the editor didn't know what to do with that string. It didn't know that it was referring to a file or symbols. It just had to rely on build time failures to make sure that you knew what to do with a failure. But now with the new syntax, Visual Studio Code can actually autocomplete the file name here, and it can autocomplete the symbol because Visual Studio or other IDEs understand that syntax. This is a web standard now, and so that's why Angular moved to that. And so by specifying that load children is a promise, it's a method that returns a promise, we actually automatically know that we only need to load that code for that module and all the things that that module pulls in when the admin route would be loaded. And this is the heart of lazy loading that we have today. So when you visit a Angular application that has lazy loading, it will look just like a normal application. All of the content will run. But when you hit a route that is needed any of the lazy loaded code, you'll see that we'll pull in only that code. So if we had that very simplistic admin module that we talked about, we only needed to load a very, very tiny amount of code over the wire. Right? We only need the minimal subset of the code that defines the new functionality within our application. And so whenever you're building a lazy loaded application, this is what you want to look for. You want to look for the JavaScript that you need loading when you need it. And for every time we lazy load anything using this dynamic import syntax, you're always going to see another network request. If you're not seeing network requests, you may have done something wrong in the import syntax. One of the key ideas when it comes to lazy loading is really figuring out the right bundles at the right time. And a lot of developers don't really understand what JavaScript they're shipping and why. And so the first step to really understanding the lazy loading strategy that you have is to start exploring your bundles. This is actually relatively easy with a tool that I recommend called Source Map Explorer. There are others, such as Webpack has built-in tools for generating statistics that can be analyzed with Webpack Bundle Analyzer. But for today, I'm going to talk about Source Map Explorer. So to take advantage of Source Map Explorer, you automatically get source maps, or this mapping between the generated code and the originating code when you do a serve, an ng serve. But I actually recommend that for most applications, even turning source maps on in production can make your life a little bit easier. You can look and monitor and understand your production bundles, even if you're just doing this temporarily. But in your Angular JSON, you can turn on source maps for production bundles by going into the configurations, and then for production, saying source maps true. And one of the other features that I highly recommend is to turn on named chunks. By default, I believe historically Angular would generate just unnamed bundles. So you'd have 9 ES 2015 4, ES 2015 3, ES 2015 14, ES 2015. And this makes debugging and understanding your bundles very, very difficult without a ton of added security. There are cases where you'll want to obfuscate your code and hide which chunks you're loading. But for most applications, it doesn't really hurt to say, hey, here's the actual module names. This isn't really exposing anything that someone couldn't find out with a debugger anyway. But within, once you've turned on name chunks, you'll see what you see on the left, where you'll actually see here's the path to the actual module file that's triggering this lazy loaded set of content, which can be very, very helpful. The other thing that you're going to see if you turn on named chunks and you do source map build is you'll find that whenever two chunks share a lot of code above a certain threshold, they will pull out that shared common code into another chunk. And this is an optimization that means that if two of your modules share a bunch of code, they can just load that code from a separate chunk and then not have to reload all of that code or not have to host all of that code independently in each of the modules. And Webpack is intelligent enough not to have to reload that common chunk if you navigate to both. Then, once you've turned on source maps for your whatever build you're going to do, you run that build. So I would run ng build -- prod to run a production build. And then I can run Source Map Explorer. You can either just run it via the binary, or you can use yarn to invoke it from the local bin folder, and then point it at the bundle. So for most applications, you will have a dist/myapp/main es2015.javascript. And so that first command would show the ES2015 for your main bundle, and the second one would show for your admin chunk if you're using named chunks. Now, as a developer, you should just go through each of the chunks of your application, and if you haven't lazy loaded yet, go through your main chunk and understand what am I pulling in and why am I paying for this on my homepage. One of the things you can do to help force yourself into some of this best practice of always using lazy loading is you can set up bundle budgets. Bundle budgets monitor different sets of code generated by Webpack and can enforce limits so you actually warn or fail your build if you exceed one of those limits. So by default in Angular via the CLI, we give you a warning at 2 megabytes and an error at 5 megabytes for initial JavaScript. Even if you are hitting 2 megabytes, you're probably shipping too much code, but we found that this is a warning that basically allows most existing applications to pass, but starts getting them set up to make better applications in the future, and also avoids dumb things that can happen as you're building applications. The craziest bundle I ever saw was 16 megabytes, and they said, why is my application so slow? It turned out that they were bundling their SVG images into their CSS, into their component scoped CSS. And so you had 15 or 16 megabytes of SVGs being shipped as JavaScript that had to be parsed by the browser, resulting in a very slow application. You would never accidentally do that if you had bundle budgets set up. Another thing that you should be doing to be taking advantage of all that Angular has to offer when it comes to lazy loading is always staying up to date. The state of tooling across the ecosystem is continuing to improve. Every year, the tooling that we build and the tooling that everyone is bringing together becomes tightly integrated and becomes more understanding of the code that developers actually write. So this shift, for example, in Angular in version 8 to the dynamic imports allows us to take advantage of more native tooling and more shared optimizations. And so by staying up to date with the latest version of Angular, you're always going to be getting the best performance, especially when it comes to features like lazy loading. It's also really important to be careful where you're doing imports, because oftentimes we pull in different features of Angular starting in a very naive place, such as our app module or app component. This is a really great way to be fast to market. You can build an application very quickly by importing everything at the root and then sharing everything across your entire application. But if you do this without thinking about the performance implications and without thinking about where do these features actually need to exist in your application, you can pull in too much and you can result in a worse experience for your users. You should be especially careful if you're pulling in other libraries like Moment or Lodash, where we've seen many, many developers accidentally pull these things in. And sometimes, especially with libraries like Moment, you can end up with a bunch of localizations where you end up shipping megabytes of JavaScript, even if you're not doing any sort of date functionality on the page that the user is visiting. One of the complexities that comes up today with lazy loading is injector configurations. Now, I am not going to be able to give an overview of how injector configurations work because this is a relatively advanced area of Angular, but lazy loading can make this a little bit more complex, especially with some of the changes that we made over the last few years. This actually happened to me where I made a big mistake where I had an application module that had two lazy loaded modules. I had a home module and an admin module. And my admin module was pulling in a auth service that was provided in root. What ended up happening was the home module could also access the auth service if the admin module had been loaded because it was provided in root. But unless the admin module had been loaded, the provided in root service wouldn't be available. This is a problem that only exists because of the lazy loading, whereas that auth service would have worked anywhere if it was not lazy loaded, if all of this code was loaded synchronously. And so you have to watch out for things like that. You should be thinking about what parts of my application need to share code, what parts of my application need access to which services, and so where should I be providing each of these different services. So provided in root is really fantastic. It was built originally to allow you to tree shake your services because by removing it from the providers of the module, we don't have to actually include it in your application unless you have a reference from someone that's actually injecting the token. But we've seen that in rare occasions with lazy loading, this can get you into trouble. So when you're thinking about lazy loading, what should you start off lazy loading? You should start off loading in your admin routes because we find that often has edit functionality. It has features that your visitors don't need. But you should also be loading in any of your editors. So maybe you have a WYSIWYG tool or a designer, you should be lazy loading those. We find that your homepage is often one of the most important experiences of your application because that's the thing that needs to load fastest. Unless someone can load your homepage fast, they can't optimistically load anything in the background. You should also lazy load any initial route. And at this point, you should basically consider lazy loading all of the code in your application. The Angular router is relatively intelligent and can lazy load only the code that people need if you're doing the right sort of modularization and right sort of architecture. And if you are lazy loading everything, you can actually use more advanced strategies such as preloading, where you, using your knowledge of your users and your knowledge of your application, can define when and where to preload these lazy loaded chunks. Preloading is a really interesting conversation because it seems counterintuitive, or it seems like a waste to be lazy loading your modules, but then also preloading all of those modules. The total net code that you're loading is probably about the same. But this is still a very, very valuable strategy, because by taking those things and then we can optimistically preload them, you can take the loading of those preloaded routes and modules and take it out of the critical path. And we can take that as another opportunity to yield back to the browser, which can improve the performance of our application. I also want to say that how you serve your JavaScript code and your lazy loaded chunks matters. One of the features that's been around for a long time as part of the web platform is called content compression, where maybe you have an admin chunk that is 900 kilobytes, but because we can compress that very well, we don't need to send 900 kilobytes over the wire. We only need to send something like 241 kilobytes for this module. So that's more than half of the file size reduced just by serving the code correctly. The bad news is that we found that around 40% of public applications are failing to compress their content or compress their JavaScript. And this means that 40% of the applications online are taking more than twice as long from a network standpoint to load than the code you wrote. And so this can be challenging for web developers, because oftentimes we are focused on the code that we write. We're focused on how the application functions, how it feels, what the experience is. But we all have to take a little bit of ownership now for the serving infrastructure, so that not only are we building great experiences, but our users are receiving those in the fastest way possible. Another technology that's really critical for serving your lazy loaded chunks correctly is HTTP2. In the HTTP1, the old model, every time you made a new connection, every time you wanted to pull in a lazy loaded chunk, you would have to initialize a new TCP connection, which meant that there was a lot of overhead. But now that we're moving towards more modern technologies, like HTTP2, you can use a single TCP connection and save a lot of the overhead, the networking, the DNS lookups, those sorts of things, which is really critical, because if you're optimistically preloading, let's say 30 or 40 modules, being able to pull all of those down over a single network connection rather than 30 or 40 network connections, you're going to save a lot of time. You can detect to see if you're using content compression in the dev tools. Again, there is a checkbox that will allow you to see all of your network requests as 2 rows. So you can see not only the size on disk, but also the size of the network. And you can also right click and see the protocols that are being used to serve your application. So you should see H2. And there's also discussions now about moving to HTTP3, but I am not as up to speed on those as some people might be. So I want to end off talking a little bit about the future, because we've seen how lazy loading can make more performant applications and how it's built into Angular. But on the Angular team, we think that there's more that we can do. For the last couple of years, we've actually been working on a rewrite of the Angular compiler and the Angular runtime. So these are internals to Angular that affect how we translate your HTML into code that runs in the browser. And if we look at how Angular actually renders today, we take your HTML templates and we turn it into this set of metadata, this set of instructions. And what happens is we have a renderer that knows all about pipes, it knows about dependency injection, it knows about sanitization, all those sorts of features. It will pull in your code and say, does this code require sanitization? Does this code require pipes? And if it does, it will execute those pipes. It will execute that sanitization. Ivy is a rewrite of our compiler and runtime that allows us to invert this. So instead of Angular pulling in your code, Ivy rewrites all of your components, all of change section, all of the runtime as a set of instructions that are initiated by your code. So instead of Angular pulling in your code, it's your code going to be pulling in Angular. Now, the huge benefit to this is that we can now leave out parts of the runtime. We can leave out instructions if you're not using them. Now, that sounds really great, but what we found is that most applications actually use most of Angular. So if you're any sort of medium or large application, you're probably using sanitization, you're probably using pipes, you're probably using all the features that Angular offers, because we built those features to make it easier for you to build apps. But when you combine the idea that we can conditionally load these things with the kind of superpowers that lazy load gives you, this means that you can build a small, fast home screen and then load the parts of Angular you need on your more complicated screens. So we really see Ivy as an enabler. So we are in the RC period right now, as you probably know, of 9.0, where we are turning on Ivy default for everyone. the first thing you're going to see if you switch to 9.0 is that we've turned on Ivy and very little will change. We have spent the last year working almost exclusively on backwards compatibility. The Angular team really cares about this idea that you can continue using your skills, you continue using your code base as we make Angular better and as we make the applications that we're shipping to the internet better for you. And so in order to kind of enable a lot of great new capabilities that we're planning for in the future, we're focusing on shipping it, moving everyone over to Ivy without changing the world, and then we can start to take advantage of these capabilities. And so one of the first capabilities that you'll actually be able to take advantage of in Ivy that we're thinking about is things like lazy loading without the router. So we started off talking about how the router is really great at loading modules. If you architect your application into modules, we can load the right module at the right time. But we can now, using Ivy, which is available in version 9 if you want to try out the RCs, or will be available soon in GA, we actually have new capabilities that allow you to do this in a different way. So we're going to jump into another live coding demo here, and we're going to take a look at my app. So this was that application we took a look at a little bit earlier. So this is just a very, very generic ng new experience from Angular. And what we'll do is we will take a look at the app component. So let's just blow away all of that starter content, and let's just say, hello, ng China. Just make sure we've got that. Perfect. So we have an Angular application. Everything is working. And now what I want to do is I want to generate a new component and a new module. So what I'm going to do is I'm going to say ngg module, and I'm going to say that this is a lazy module. And then what I can do is I can jump into that module, and I'm going to generate a new component, also called lazy. So what I've done now is I could use traditional routing if I wanted to load this module and to load the component into the router outlet, but I don't want to do that this time. What I want to do is I want to use my app component here to conditionally load that component without the module and without the router. And so what I'm going to do is I'm going to create a div, and I will label it here as output. So we have a marker of where to put our lazy component. And now let's get a handle on that. Let's also make a new button. So let's say button, and let's create a load function. So let's go ahead and define both of those things. So we'll create a load function, and now let's get a handle on output. So output, we are going to use a decorator because this is going to be a view child called output. And instead of getting the access to the template, what I actually want to do is I want to do read view container ref. Because view container ref is in Angular how the underlying tool that we use to actually instantiate components. All right, so we've got a view container ref, and let's just type this as a view container ref. Perfect. So we now have a place where we can put our component. And now I'm going to need one more thing. So this is just a legacy of the backwards compatibility with the old compiler and runtime, but I'm going to need access to the component factory resolver. So this is the service that used to turn types into component factories so that you could actually use a type to refer to a component. So now that I have the component factory resolver, what I want to do is I want to create this load method, and we're going to say const, and we're going to say lazy component equals await import. And again, this is where you're going to use a industry standard dynamic import syntax. And so you get this nice Visual Studio Code autocomplete. And we can say load my lazy component. And for await to work, we're going to make this function async. And now what I can do is I can use the output to create component. And I'm just going to pass it the lazy component that we just loaded. And what should happen is, we need, as I said, we need to resolve the component factory. So we're going to use this .cfr .resolve component factory. So we've written about 3 lines of code here. We've got handle on the output, which is of type view container ref. We are doing a dynamic import of the component when someone calls the load function And now we are attaching that into that next to that view container ref using create component. So what should happen is, because we're using Webpack under the hood, our build tooling should automatically identify that this is a dynamic import. And if we take a look at our ng serve, let's see if we reserve. I think this worked. I think I just fat fingered it, or it did a build while we were still writing code. I think we're okay. Let's give this a try. Failed to load. Okay, we actually did write a mistake here. You got to save your file. Whenever you make changes in Visual Studio Code, apparently you have to hit the save button. This is a really advanced strategy for web developers. Let's try serving again. I may have made a bigger mistake than I thought. All right, it looks like it was successful. And one of the things we can see is we see the path here. So you've got /lazy/lazy, and we have our lazy component. Webpack has detected that this was a set of JavaScript to render out. So it rendered that little 2 KB bundle with the functionality for that component. And now when I load the page and I open DevTools, we should see that when I click load, we have now loaded that component and bootstrapped it into the application. And we can see that our lazy component works. So again, yeah, thank you. So we've never previously been able to do this outside of the router. You had to rely on the router magic and the way that Angular load modules. But now, because we are always on a mission to be as standards-based as possible, these kind of new capabilities are coming to us because of Ivy. All right. So to wrap up, we've talked about the current lazy loading best practices and how everyone should be taking advantage of them. If you see any reason you shouldn't, come yell at me, come yell at Zach, come yell at any of our GDEs or any of our community members, because this is really on us to make it as easy as possible. But in the future, we are going to keep making Angular smaller, faster, and easier to use, because we have this vision that if you can keep taking advantage of web standards, keep taking advantage of the same skills and capabilities you have today, it's our job to keep taking the existing applications out there, making them better, and taking them further. Thank you so much.